Good afternoon, everyone. This is Jonathan Volk with CASIS. Thank you for participating in this webinar to discuss the Alpha Space MISSE solicitation. To begin, us from the CASIS side will be going over just a brief overview of the schedule of the proceedings for the remainder of the duration of the solicitation. Then we'll turn it over to our friends at Alpha Space, who will be giving you an overview of the platform and the capabilities. Then we'll be closing the webinar with hopefully a large Q&A. And just as a heads up for everyone, these slides will be posted and this webinar will be sent out. The recording will be sent out if you'd like to use it for follow-up resources. Okay, so just a quick overview of the timeline. Here we are today on Tuesday, February 20th with this webinar. A week from Thursday, March 1st, the Step 1 proposals will be due by 5 o'clock Eastern Time. Those Step 1 proposal forms can be downloaded directly from the solicitation website. The forms can be filled out either in a Word document or scanned into a PDF and emailed directly back to the email address shown on the solicitation website. Because of the quick turnaround, we'll be getting your status of these Step 1s back to either yay or nay to submit a Step 2 by the following Monday, March 5th. And we'd like to get you an answer as soon as possible because the due date for Step 2 proposals are about 3.5 weeks after that on Friday, March 30th. So hopefully that'll give you enough time to complete a Step 2 proposal should you be invited to submit one. The announcement of the winners of the solicitation, we're hoping to do that sometime in May, and then an approximate date for now, a quick turnaround and a launch date of these projects to ISS toward the end of the year 2018. So that's a high-level view of the schedule. We can talk about this farther if you have any questions in the Q&A portion of the webinar at the end after Alpha Space gives their presentation. So with that, I'll turn it over to Johnny Englehart, the Manager of Programs and Product Development for Alpha Space. Will give you a nice overview of the capabilities of this platform.
Okay, this is Johnny Englehart. I've been with the MISSE program since it started on ISS in 1999. So I've got a little bit of history with flying material samples, and we'll just go ahead and head into the presentation. Okay, I do not have control yet. There we are. Basically, MISSEs 1 through 5 were standalone, 1 through 4 were non-powered. MISSE 5 was self-powered, attached to the ISS. When MISSE 6A and 6B came along, it was powered through the Columbus module. And then 7A, 7B, 8A were all powered through the Express pallet on the ISS. We went ahead and started the flight facility development in 2015 as part of a bid process with the ISS Payload Office. Okay. The evolution, it started out, like I said, the history started out in 1999. In 2015, Alpha Space signed a cooperative agreement to commercially fly materials research on the ISS. Due to our location, we have zenith, nadir, RAM, and wake views. The nadir views are not exactly the best in the world. We are looking, with our cooperative agreement, we have 6 and 12-month rotation cycles. We have near real-time on-orbit data and commanding. And the reason I say near real-time is there's a 12 to 20-second delay from getting a command to the ground using the ISS systems. If we could go ahead and we offer a turnkey approach where you provide us the samples and we go ahead and go through and take it through the integration, verification, safety processes, and fly the samples on orbit. Could go to the next slide, please. One of the things that's unique about MISSE is that MISSE allows you to simultaneously test all aspects of space flight on your samples and your experiments in the orbit environment, the low Earth orbit environment. With our near real-time monitoring, we know the temperature cycles, we know the position around the Earth, we know what the radiation effects are pretty much constantly around the Earth. When you go through the South Atlantic anomaly and get high in the inclinations in the ISS orbit, you get a lot higher radiation dose. You get 16 thermal cycles per day because it's 16 orbits per day, so you're going to go through day and night cycles. The UV ionizing and electromagnetic radiation that you're going to see on orbit, the radiation part of it is inhibited by the Van Allen radiation belts, but the UV, you get all of the UV light coming through. If the second the UV hits the atmosphere, you lose 90% of UVB, and at that point in time, testing on the ground, unless you're in a vacuum chamber that's specially equipped, you're not going to get there. You also get plasma environment, micrometeoroids, and if you're testing for atomic oxygen, you get both the atomic oxygen and the wake exposure for your control of your science sample. It allows to actually fly a true experiment where you can determine if atomic oxygen impacts are the key features that you're seeing. And again, you get all of this simultaneously on the facility. Next slide, please. The MISSE is located on ELC, will be located on ELC2 Site 3 when SpaceX 14 arrives at ISS. We have designed the facility such that we can protect from on-orbit contamination from visiting vehicles because we have the ability to close our hardware to protect the samples. Previous MISSEs did not have this capability, and you could actually see damage being done by visiting vehicles on the science. If you take a look at the samples, you're going to see the accelerated test results because you're getting pure exposure. You're not getting a limited exposure in one test facility on the ground and going to another. It's a simultaneous exposure. Our design is basically we have a central structure with sample carriers. On the left side of this picture, you can see the sample carriers in the closed configuration. On the right side, you can see them in an open configuration. And what this does is this allows us to fly them up internal, protected from the environment, put them outside, open them up, expose them, and if there's, for whatever reason, a contamination issue on the outside of ISS, be it an ammonia leak, a visiting vehicle coming in, we can go ahead and close the MSCs to protect your science. We also have a high resolution camera system that we'll go into in a little bit further. I believe it's on the next slide. Next slide, please. Okay, the upper left-hand picture on this slide is the MSC Variant 1. What you'll see is we have two decks where the science samples are mounted. We have a scanner trolley assembly that basically has cameras in it. We will move down, take pictures on a monthly basis so that you will have photographs of your samples so you can determine if there's anything that you're seeing on the samples while it's on orbit. Now, to make sure that your pictures are all of equivalent value, we are going to take the pictures on the dark side of the orbit with our own light source so that there's no reflection or anything else in the samples that could confuse or disrupt the ability of the system, of your analysis of the photographs. The standard dimensions are on the right side. Basically, it's 7.8 inches wide, 3.75 inches deep, and about 14 inches on each of the trays. Caution though, the depth on the attachment side, which is the right side of that picture, is not the full 3. And other assorted hardware under that deck. So that deck depth on that side is going to be a lot less. Each of our carriers is equipped with the sensor suites that you see up there. The standard is the TQCM and the temperature for your sample deck. Optional services that we provide, total ionizing dose radiation, atomic oxygen exposure, and we are also doing a UV sensor so we can determine the actual UV level that you're actually seeing per orbit. Next slide. This slide basically shows how historically all MISSE samples, passive samples, were mounted. Basically, it's a barbell stack of washers with the sample being pressed against the top part of the deck. Left side of this picture is a 1-inch diameter circular sample. The right side is a square sample. And this is basically a representative of that. We can handle any size circles or squares as long as they fit in the 7-inch by 14-inch area of the deck. Under deck, on the swing side that you see here, we have the ability to mount powered samples that are basically instrument checkout. We have 28-volt availability. We also have a 422 interface so that you can actually get actual runtime data down from your experiment on orbit. Next slide, please. Our Variant 2 carrier is basically set up for work with solar cells and other stuff where you do not want the shadowing and the pictures are not necessarily required. If you want pictures of your samples, we have to fly the cameras. If you don't need pictures of the samples, but you want to go to a slightly larger area, then we can go ahead and go with the Variant 2 carrier. This picture shows a lot of open space on the attachment side, which is the left side. There will be a computer and everything else mounted on that side, so the full depth will not be available to experimenters. Next slide. Our data and operations capabilities. We have a 422 interface for experimenters to use. It will allow you to send commands to through the ISS to your experiment, and it will also allow data from your experiment to the ground. One of the things that we have also put into the system is an isolated Ethernet that does not connect to the ISS Ethernet for large file transfers, but actually allows you to connect between two different MSCs on the facility, so that if you have a data reduction computer that needs to be flown, and it will not fit under the deck in the MSC that you're in, you can actually transmit the data across this Ethernet, and it will go ahead and allow you to process the data in another box on the facility. Our POC will be where we do payload command and control on the MISSE. If you want to do command and control and you need to do command and control on your experiments, we utilize the TREC system, which is a telescience resource kit. It will allow you to send commands to your payload or to your experiment, but we have to authorize you to send those commands. And when we authorize you to send the commands, you can send whatever commands during your window for commanding. So if you, and you will coordinate your windows for commands through us, and we will coordinate that to the ISS program. That way, we are the interface to the ISS program. You don't need to worry about that interface. You just interface to us. If you have an active experiment, we will develop a GUI for your active experiment, and that will give you the temperature range and your data downlink capability so that you can actually watch the data as it comes down. Next slide, please. Our integration timeline for this particular setup, we will provide you an IDD at the L-12 timeframe. Yeah, November is, we're inside that window, but that is acceptable and that is okay. What that means is that instead of a sample drop initial at L-12, we will require the information for the first IDD update to be filled in with that at this point in time. All of this leads up to us developing our Phase 012 safety package that we have to turn over to NASA. After we turn over that package to NASA, then we're going to go into the CDR process, and the safety process is basically a simultaneous schedule so that we can go ahead and provide the appropriate data to the ISS program so that we can have your samples on orbit appropriately. We have set it up so that our facility and our MSCs provide the majority of the safety inhibits that are required by the NASA program. So that eliminates a lot of the safety requirements from your payloads. There are some things that we cannot do anything about, and they're listed on a slide further in the presentation. Next slide, please. Matter of fact, this is it. Past experiments have been passive samples, coatings, polymers, fabrics. Shatterable materials are a common thing that are flown. Active experiments, we've flown solar cell performance experiments. We've flown electrical experiments where you actually are running a computer on board, generating data, downlinking that to verify operations in the LEO environment. We've run time exposure experiments where basically the system has had a shutter system installed so that every month one of the shutters closes. So you basically have a timed exposure in atomic oxygen on your sample so that you can actually track the degradation of your sample with respect to the length of time in atomic oxygen. We've also done some solar cell arcing experiments where they have a 600-volt negative ground plane that they established in the plasma environment around the ISS, and they actually recorded several arcs to the solar cells. The experiment was a success and showed everything that was necessary. We've also flown biologicals. By biologicals, we mean seeds have been flown. Viruses, several different viruses were flown to see what the effects of space-based radiation are. Bacteria the same way. Cotton was also flown as a experiment at one time. What we can accommodate with the current facility design, we've advanced it to where, one, we can accommodate anything similar to what has been flown before. We can now accommodate high data rate experiments. We can accommodate more powered experiments. We can accommodate larger technical demonstrations, i.e. we can accommodate transmitters, optical viewing experiments, complex systems verification, where if you've got a computer that needs to communicate to another computer across a copper path, or even a wireless payload on another, or a wireless receiver on another payload. We can actually work with that. We can also accommodate 3D printed materials, because our structures path does not, any of the 3D printed materials will not be in our structural load path, so they can actually be flown and tested on orbit. There are a couple of restricted materials that we cannot fly. One of them is sulfur-based materials. That's batteries or coatings that can generate particulates. And the reason for that is the ISS contamination, the ISS CO2 removal system has a catalyst bed on the front end, and the sulfur interferes with that catalyst bed. It took us the longest time to get that out of everybody when we were trying to fly thionyl sulfide batteries, and they finally came up and said, here's the reason why. And once we told everybody, this is why you can't fly your thionyl sulfide batteries, your thionyl chloride batteries, basically everybody said, okay, fine, we'll go to something else. So nickel hydride, metal hydride batteries were a good replacement for that. But the sulfur interferes, and there is no way that we're ever going to be allowed to fly anything that is sulfur that can get loose inside the cabin. And since we have to go through the cabin to get to the facility, that automatically makes sulfur-based materials a non-starter. The other part of this too is the standard crew exposure hazards. Some processes use arsenic or cyanide in the development process, in the manufacturing process, and inevitably some of that stays behind in the material as it's being made. So those are also forbidden on orbit in the habitable volume as well. Other than that, that's pretty much the only restrictions that we've come across that have ever held. And really, there's no way to argue around any of those. But pretty much anything else can be flown. I believe that's the last slide, right? Mm-hmm. All right. We're at the discussion part of this, so what we'll do is we'll go ahead and turn it back over to the guys at CASIS.
Hi, Johnny. Thank you. That was great. I want to remind everyone now who's on the webinar, please type in your questions or comments, and we'll go through these as they come in and do our best to answer them right now. If we can't answer them real time during the webinar today, we'll certainly reach back out when we have some clarifying answers and get responses to you as soon as possible. We have one question that's been submitted inquiring as follows. I'm currently submitting a NASA SBIR for a MISSE FF experiment for a NASA SBIR funded technology. Could I recycle that proposal for a submission to CASIS? This is totally passive experiment. So the answer to that question is yes. I see no reason why you could not recycle or repurpose that NASA SBIR proposal and submit to the solicitation. However, I would remind you that this solicitation does not come with additional funding. The awardees from this solicitation will receive a total scope end-to-end payload development, mission integration operation, and payload hosting on the Alpha MISSE FF facility, but there will not be actual dollars awarded to any of the recipients.
Next question is, when will these slides be available? We will make them available by this time tomorrow. meaning Wednesday.
Next question, Johnny, I think this is for Alpha Space. The question is, what telemetry and MISSE do you provide? In what ways and what pace? So I think what they mean to say, what telemetry from the MISSE will be provided. So what sort of data, and do you have an idea what the cadence is, Johnny, as far as the data coming down from MISSE?
Okay, our current data rate is 2 samples per second. If you need a higher data rate, we can always drop it on the high rate data system, which dumps data down at around, well, it's rated at 10 megabits per second, but actual throughput is on the order of about 3 megabits per second. For large files like that, what we would suggest as an organization is to record that as a file and then downlink the whole file. Because if you try to bring it down real time, you're going to have handovers between TDRSs that get in the way. And when your data comes down, it's going to be stored on orbit, and then the immediate downlink is going to pick up, and then they are going to be sending down the other data that's in storage as available bandwidth comes open. So what you'll end up having to do at that point in time is replay back from the host. So your best bet is to downlink the data as a file. Again, the payloads have a 422 connection. The experiments have a 422 connection. And I believe we're operating the 422 connection at around 1 megabit per second. So that's about where we're at with the system. So, and normally we will provide, we can also tap into the ISS system for position, attitude, and all of the ancillary data from the spacecraft.
Position, attitude, temperature.
Well, right.
Okay, next question. Again, this will probably be for Alpha Space. Have you ever flown any RF experiments on MISSE? If so, what type?
Let's see. MISSE 5 was an RF experiment all the way across the board. It used a ham transmitter to transmit the data to the ground because the MISSE 5 was a standalone self-powered MISSE that was operating on the top of P6. The MISSE 5 was a self-imposed transmitter. What we have been looking at, we are also flying Dust Shield as a NASA payload, I believe on MISSE 10, which is an RF generator. So it's another, another thing where we can just go ahead and we will analyze you with the other payloads that are on there, and then we'll figure out the appropriate use committees and frequency committees that have to be assessed for operations transmitting from space.
Okay, Johnny, thank you. Another question. We have an interested party in conducting a wear or friction study, tribology study. How much depth could one get in packaging an actuator into the MISSE platform?
An actuator in the MISSE platform, as long as it would fit in the 3 by 7 by 12-inch volume. Depending upon orientation, you could package an actuator in that volume, and you could actually run at that entire volume.
Okay, thank you. So those are the dimensions actually that we saw earlier in your presentation, and once again, probably within 24 hours, we'll get these slides shared with all attendees. So some of that technical detail and data can be found in the slides.
Correct.
So Johnny, we have a question about concept of operations. Can you give us a little bit more of an overview, a little bit more detail in what the concept of operations is, a ConOp scenario?
Okay. Basically, we have to coordinate with the ISS 2 weeks prior to any activity occurring on ISS. We have to coordinate with the POIC. What we will do is we will coordinate a time frame, so we need everybody's request for operations in 2 weeks prior to. We discuss this with the POIC, and once we have your area, we will get you a block of time to do your commanding. If you have a simple passive experiment and you're recording the time, temperature, and position data, that will come down once per second, and you can have all 3 million plus samples per year. Basically, we provide all of the interfaces to the ISS community. So you are not, what's the right way to say this, contacted by multiple different organizations that support the ISS. Your contact is with us, and we handle all of the contact with the ISS program. And through the TREC system downlink, you have the ability to watch your experiment being performed on orbit.
All right, thank you, Johnny. I think a follow-on to that question, it wasn't apparent whether or not the MISSE flight facility will be inside ISS before going out to the GEM airlock. Can you just clarify that, please?
Okay, the flight facility itself will be launching external on the on SpaceX 14 and be installed externally. The sample carriers will be transported up internally, passed through the Japanese airlock, transferred out to the facility, and installed on the facility. And then they'll be returned the same way. And I guess one of the key things is everybody needs to realize too is the fact that you do get your samples back at the end of the year on orbit.
Okay, thanks. Next question. Which face exposure, RAM, wake, zenith, nadir, have you seen most MMOD effects acquired on previous experiments?
The RAM side.
RAM side, yep.
You're flying into the debris, and you're flying at 17,500 miles an hour into the debris field. Wake, you'll see very little. Zenith, every once in a while, you'll see some. But majority of time, it's the RAM side.
Okay, thank you. Next question. 28 volts was mentioned as an available power metric. Are there other power limitations for flown systems?
The power that we are providing for experiment use is basically 3 amps at 28 volts. We can go as high as 4.5, but we have to be very careful so that we do not trip out our power converters. The problem with utilizing an awful lot of power on ISS and any space vehicle is the dissemination of the heat that is generated as you're consuming that power. So you must be very mindful thermally about generating that much power or utilizing that much power in an experiment operation. So 100 watts at 28 volts is pretty much the norm that we have allocated comes out a little over 3 amps, but if you stay at 3 amps, then there shouldn't be any issues.
All right, next question. What kinds of payload verification testing and pre-launch processing are we responsible for?
Okay, all you are responsible for is providing us the material samples. We do all of the pre-launch verification with the ISS program. The science verification pretty much is what the PIs will be responsible for. All of the system verification to the ISS. If you fill out the IDD and complete the IDD when you hand over your sample, that will give us the information that we need to verify the system with the ISS, and there won't be any questions.
Johnny, this is an interesting question. It's not necessarily technical, so we'll take a shot at it anyway. Have you seen customers who initially planned for a small sat experiment and found that they could execute the same experiment on the MISSE?
Actually, we're the ones who have actually proposed that to multiple small sat people who want to fly instruments, because with the failure rate of small sats, you will not, you'll get put out on orbit, but at a 50% failure rate due to comm failure or power system failure or whatever due to the small sat, you'll never understand why if it's your instrument or if it's the satellite that actually didn't work. With us, if you fly that instrument on our system, then if it has an issue, when you bring it home, you can do a post-mortem on it and determine what happened. So we would, our personal take on this is we should fly the instruments to where we can get them back and prove that the instrument works before we put it on a satellite of some type and send it off into orbit.
Thank you. Next question. Are there concerns or precautions for passive exposure experiments that may generate limited outgassed volatiles?
Contamination is always a big thing on the ISS. If it is part of the science that is being gathered, the issue is there, but in reality, you are grouped in with everything else that is on the MISSE facility at that point in time. So if there is a limited outgassing of volatiles, that is expected with the science. And as long as it's not a major contributor, then the samples can be flown without any issue.
Next question, we'll take this one. CASIS will take this question. What type of final products or dissemination of results is usually expected from this type of grant? Is publication in an open access journal required? So we'll take this in reverse. No, publication in an open journal is not required. It's awfully nice, and we do have a lot of our results that you can see in publications and journals. The types of reporting and product dissemination, it's wide-ranging and would vary according to the objective of the investigation. And the exact final reporting is something that we could, in all honesty, negotiate through the agreement process. Typically, though, we would want to see some form of a final reporting that is providing in some level of detail results of the investigation. How well did the results align with what the objectives were, and what sort of application would the results be translated to, perhaps? Next question. I understand there is no funding with this award. what is the approximate cost what is the approximate cost to participants for a passive experiment? I think those costs could be wide-ranging and variable on what is the material that you're testing, how extensive will ground testing be required, what sort of safety protocols may we have to take into account to get your flight certified. There really is no way for us at this juncture, without understanding any parameters of a proposed project, to even approach a rough order of magnitude as to what the cost would be. It is our anticipation that all internal costs will be absorbed by the awardees. Next question. Is there any new capability added for active solar cell performance experiments on this MISSE as compared to previous MISSE missions?
We are actually actively engaged. It's been put on the back burner since we're getting the facility prepped for flight, but we are actively engaged in getting the circuitry necessary to do solar cell performance measurements, IV curves on orbit. So the plan currently is to implement that in a Variant 2 carrier so that we can actually do solar cell. We're looking at the ability to do both solar cell calibration and solar cell performance testing on the ISS.
Next question. For solar cells and cover glass, can the IV data be measured and downloaded during the mission?
Actually, yes, it could actually be done real time. So that as it goes through each solar path, the data will be transmitted to the ground. Again, we're running through the 16 cycles per day, so it's 16 data takes per day times 365. So there will be an awful lot of data for the individual cell provider to wade through.
Excellent, thank you. Next question. How can we find out a ROM cost for required ground testing, extra safety protocols, etc.? Who should we contact with these questions? These are questions that we will delve into once we begin the proposal development phase in supporting different project or investigation specific questions. Those questions may be answered by either Alpha Space or CASIS. For early questions, I would encourage you to submit inquiries like this to opsinfo@iss-casis.org. And if we don't have the answers, then we'll work through our colleagues at Alpha Space or NASA to get the answers required. Okay, that's all the questions that we've received thus far. We will hold on the line here for about a minute or two to see if any other questions might be coming in. We have another question. Does CASIS include any pre or post characterization of cover glass, solar cell, or CIC assemblies? Typical data for cover glass would be percentage of transmission and percentage reflection to determine effects of ionizing radiation and or ATOX. Atomic oxygen. I don't have a good answer for that. We would have to understand more detail regarding the requirements of the pre or post characterization to see if that is something that is either within or out of the scope of what Alpha Space is providing through just the nominal mission award. So we'll have to revert on that after we learn more details. Okay, we have another question. Johnny, can you describe the TQCM on the standard sensor suite once more? And are the optional sensors, UV, atomic oxygen, etc., an added cost?
The TQCM that we're running on this, we're going to be receiving the downlink data on. As for the specifics, I'm not at this point in time willing to divulge that. We did have them, we have tested them, and they do work and they do collect data in a vacuum. And as for the optional sensor suite, yes, they are an added cost.
But Ken, maybe you want to address the cost portion of the question for the CASIS call.
Yeah, sure, I will. Thank you, Stephanie. So folks who might be interested in some of these other sensors should include that in their proposal, and Alpha Space would apply their ROM estimate to what those additional sensors would cost, and that would be could be a portion of the award. So it could be included in your end-to-end total scope mission award. Another question, Johnny, are ISM band 915 megahertz low power transmitters allowed? Our experiment involves testing ground-based signal processing equipment for receiving low power long range transmissions.
Yes. One word answer, yes. We would need to work the full details of it, but yes, that is a possible capability.
Super. We've got a clarification question here. Approximate launch date for samples would occur in November 2018, meaning samples could return as early as March 2019.
That if everyone in that carrier where that's mounted wants to come back at 6 months, yes, that is correct.
Yeah, I think this scenario, the November 2018 launch date and return of March 2019, I think that's all dependent on, several factors. It depends on, what is the material? Is it active? Is it passive? Is there going to be any sort of special protocols that we're going to have to follow to get things flight certified? So certainly that timeline is possible, but will be dependent on exactly what investigations are awarded. Another question, Johnny. Are there any concerns for experiments that may generate a mechanical impulse or brief vibration relating to neighboring experiments? So I think the answer to that is yes. Having said that, I think that Alpha Space and our colleagues at NASA would try to understand what the requirements and objectives of the investigation are and see if a solution could be worked. Johnny, anything to add there?
No, actually, that is the exact correct answer. We would need to better understand what that is. There is a requirement on the ISS books that say vibration is bad, but there are also dampening systems that could be applied that would actually help and minimize the impact to other payloads on the ISS, and also other samples on the MISSE. So yes, we would need to further understand the experiment and why and all the other stuff, and then we can come up with a system that will actually work to meet all the requirements.
Okay, Johnny, we have a question about max time on orbit. I believe nominal time on orbit is somewhere between 6 months and 1 year. Is that accurate?
Yes, sir. Now,
go ahead.
If the experiment and everybody else in that carrier wants to go longer on orbit, we can set up a carrier to do that. It depends on the other samples that are going to be mounted in that carrier. Because if everybody on that carrier wants to be there for 2 years, that carrier could be installed and left there for 2 years or 3 years. I don't think the cameras will survive much past 4 years, so the radiation strike from the CCCDs might take the cameras out somewhere along the 2 year or the basically 30-month time frame. But yes, we can leave the carrier external for longer than 12 months.
Okay. We have a question regarding biological samples. Is it possible that spores could be allowed to be flown with these missions?
Yes. We would have to understand the requirements to keep the spores alive and any fixatives that would be required once the experiment is done to fix the spores for scientific research afterwards, but spores could be flown.
Johnny, we have a question that's come in regarding how much area might be available in total for active solar cell experiments.
The active solar cell experiment area basically, let's see, do we still have control? If we could go to the Variance 2 carrier slide, I think it's slide 12. It basically has basically it is the area that would be exposed would be the 8.5 by 15.5. The electronics to measure the IV curves would be mounted below that under the deck.
It could be times 2.
Times 2, depending upon how much the computer and everything take up on the other half of the carrier. But yes, so you could actually get basically a 30-inch by 8.5-inch, but it would be a split panel because the hinge has to open so that the carrier can be exposed on orbit.
All right, thank you. We have another question. Can a proposer be an individual or maybe partner with any local organization within the national or international organization? So yes, a proposer can be an individual. It could also be any type of organization in the United States. This call is limited to United States principal parties of interest, but they could be individuals, they could be other government agencies besides NASA, They could be private companies, non-for-profits, and universities. So there's really no limitation on the type of organization. Next question. Is there currently space for samples to fly on any of MISSE's face exposures, RAM, wake, etc.? Or will there only be certain space available on certain faces?
Yeah, we are handling the logistics for each of the samples as they come in to meet the science requirements. This is one of those things that has to be run through. Our cooperative agreement says NASA gets 40% of each carrier that goes up. They can trade their space around in every, and allocate their experiments how they see fit. But all of those will be worked in with anybody who shows up at this call or independently.
Okay, I don't think we have any other questions at this time. Please feel free to send any follow-up questions to opsinfo@iss-casis.org, and we'll get you the information that you need. If need be, we certainly reach out to Alpha Space to get answers there. Those could be technical or process related questions. We appreciate everyone dialing in today. There's certainly a lot of interest being generated by this solicitation, and we look forward to several awards to get some interesting materials and or technology investigations on board the International Space Station's National Laboratory here in the very near future. With that, we'll close off the webinar, and we'll wish everyone a very good evening, and we'll talk soon. Thank you.